real pleasure to introduce Ruth DeFries to you. I've known Ruth for quite a long time. We were graduate students together at Johns Hopkins. And from that Department of Geography and Environmental Engineering, Ruth has had an amazing career, a very distinguished career in this whole arena of what I would call an Earth system science perspective on land use and land cover change, how it affects biogeochemical cycles around the planet, and protection of biodiversity, a number of other topics. She's been at the University of Maryland in the Department of Geography for quite a few years, but before that was also with the National Research Council for a while. Very productive, very prolific researcher and publisher, recognized by her election to the National Academy of Sciences within the last couple of years, as well as a MacArthur Fellow. I can say I knew her when she was just a lowly graduate. She's ascended to great heights, and it's really nice that she's been able to take the time to join us here for this presentation, Changing Dynamics of Tropical Deforestation, Atmospheric Carbon, where science meets policy. I should say this is also a long-standing interest of Ruth, is to think about that interface between science and policy. And another place I saw her recently was as an Elder Leopold Fellow, so she's also part of that fellowship program, which is really for people who are interested specifically in how science meets policy. So without further ado, it really is great to have you here. Thank you for coming.
Well, thank you so much, Frank. It's really great to be here, and thank you for the invitation. And it's been a pleasure talking with many of you this morning about this very issue and seeing how we all really need to work together to address what we've known for quite a long time now is an issue, tropical deforestation, as one of the human activities which puts carbon into the atmosphere. So the issue on the table right now, and it's a very engaged policy discussion at the moment, is how can we put in place policies, thank you so much, BJ, how can we put in place policies that provide incentives for tropical countries, which is where the deforestation is currently occurring, policies that promote the keeping carbon in the forests rather than being burned and going up into the atmosphere. And if the bottom line of what I want to say today, I think all of you know, being in this school, is that the science issues are challenging and difficult and give us some degree of job uncertainty because there's a lot of uncertainty. But the difficulty of the science just pales in comparison to the difficulty of the policy discussions and the international policy issues which are raised by how we might put in place some policy issue aimed at reducing emissions from deforestation as one of the ways to mitigate carbon. So that's my message, is that science is difficult, but policy is even more difficult. So the work I'm going to talk about today involves remote sensing, modeling, field work, and a large number of collaborators which are listed here, and funding mostly from NASA. And before getting into the part of the world where I've been working, the southern Amazon, which is what I want to focus on today, I want to step back a little bit and look at the broad issue of forest cover and deforestation through the sweep of time and space. And that if we think about what's on the land surface and how humans have modified the land surface, we can generalize very generally, because of course every place has its own specifics, that if we think about the process that we went through, for example, in this country, what's happening here? Here we go. A period of frontier clearing, which occurred a few hundred years ago in our part of the world, before that, prior to that in Europe, and perhaps a period of subsistence and small-scale farms where there's some stable forest cover, and moving towards a period of intensive agriculture. Now, not every place clearly goes through these transitions in any kind of linear fashion, and some places might go through one stage of this transition and stay there for a very long time. But if we step back very far and think about the land use transformations on the landscape, we can generalize into an overall pattern such as this. And in terms of forest cover, which is the most observable mark of human presence on the landscape, or one of them, the period of frontier clearing accompanies a reduction in forest cover, a period of stable forest cover, and as occurs sometimes in this country, in European countries, in some countries, Korea, India, China, some other countries, where the process of movement to intensive agriculture and a urban, large proportion of the population living in urban areas, a time when forest cover increases as the less productive parts of the landscape are abandoned and tree cover increases. So that's a very, very general statement, and of course the details vary in particular places. But if we think about the tropics, there are different countries which are different at different points along this trajectory. So of course the issue that we're currently thinking about in terms of the carbon emissions, where deforestation is occurring, is basically the Amazon countries, Southeast Asia, Indonesia, to some degree Central African countries. But this is where the issue is focused in terms of deforestation currently. Quite a number of other places are in a kind of stable period of forest cover, India being one of them, although that there seems to be some indication there's an increase in forest cover, and some countries where there's increased forest cover over the last couple of decades, for example, Costa Rica, China, a few other countries. So what we're aiming at in terms of mitigating climate change and reducing greenhouse gas emissions is focused on the carbon CO2 emissions to the atmosphere, because this carbon, which is stored in the forest, then gets burned and decays and gets up into the atmosphere. But if we think about it in terms of the overall greenhouse gases, the methane, nitrous oxide, other greenhouse gases come into play throughout this kind of land use transition. But this is the current policy discussion and the current focus. And when coming back at the end, when we talk about the policy implications, one of the difficulties comes in because all of these countries, which are at different stages along this transition, if there are carbon credits for management of forests, all these countries rightfully would like to get a piece of the action. So that sets up a policy question right off the bat. So we'll come back to that. But if we think about the historical emissions from land use change, and Ski Houghton at Woods Hole Research Center has spent a whole career on this. Here it is. His whole career on this question. We know that today the big issue of climate change is related to fossil fuels and energy. The land use piece may be about 20% or maybe even less, between 15 and 20% of the overall emissions, carbon emissions from anthropogenic activities. The big issue is the fossil fuel. But if you look historically, going back to 1850, this light green is the carbon emissions from land use change, and in this part of the historical time period series, this is us, this is the temperate part of the world, where the emissions from land use change were greater than the emissions from fossil fuel. And when we get into the 1950s and so on, we all are very familiar with what happens with the fossil fuel story, and this is likely to increase further. So the deforestation piece is likely to become less and less of a percentage, but that is one of the possibilities for mitigating climate change, is to try to reduce this piece. Although not the full story, because there's quite a lot of work to do to get at the fossil fuel source, but the focus here is on just this piece. So since the 1970s or so, this emissions from land use change is basically the question of tropical deforestation. Going back in time, it was in a different part of the world, but since this chunk here, it's pretty much all tropical deforestation. So the policy issue on the table right now is this discussion within the UN Framework Convention on Climate Change, is to develop a policy, RED, which is reducing emissions from deforestation and degradation. In the discussions which led up to the Kyoto Protocol, the idea of deforestation or providing carbon credits or or targets for deforestation at a national scale was off the table, ostensibly because it was too difficult to monitor, to measure. How do we estimate the emissions? So it just wasn't part of the discussion. What is in the Kyoto Protocol is a project-based approach where there can be some offset through the clean development mechanism for projects which sequester carbon through afforestation and reforestation. But deforestation is not in the current Kyoto Protocol. So the discussion which has been in play for the last couple of years is for the post-Kyoto commitment period. Should there be a policy which targets countries in the tropics aimed to reduce their emissions from deforestation and degradation? So this was quite a huge topic at the Conference of Parties which took place in Bali last December. And the issue is now in the Bali roadmap, and it was in Bali, this Conference of Parties was labeled the Forest COP. I'm not sure if that's how it was played in the press here, but sorry about that. But at the meeting itself, the focus on forests and deforestation was enormous, really permeated the whole meeting. And what came out of it was a lot of sort of policy ease here, a lot of words, and basically they don't say much. But what they do say is that the parties will continue to discuss the development of policies aimed at reducing emissions from deforestation and degradation. Nothing concrete, no commitments, but it is on the table now for discussion. So there's quite a flurry of activity, and I talked with several of you this morning, and you're involved in this discussion on how do we move forward, how do we integrate what we know from the science, and how do we develop these policies aimed at reducing emissions from deforestation, again, as one approach for mitigating climate change. So that's the policy context. When we get to the science and just step back outside of the realm of the policy and see what's the state of understanding within the science, there's a literature about the carbon emissions from deforestation, but it's a rather uncertain literature, and there are estimates of emissions from tropical deforestation for the 1980s, the 1990s, and they vary. There is a rather high degree of uncertainty around them. There are a few different methods. There's a sort of bookkeeping accounting method. There are different modeling approaches, and different studies cover different geographic areas, different spatial scales, different analytical techniques, different input data sets. So it's really not hard to see why these estimates that exist in the literature vary to the degree that they do. And when you look at what needs to go into these estimates of carbon emissions from deforestation, you see why these estimates can vary widely. What we're really dealing with here is the carbon emissions from deforestation. So you have an initial loss, which is basically fire, because deforestation in the tropics, and as it was here, is about fire. It's really a fire emissions problem, that's the cheap and effective way to get rid of all this biomass which is in the way. So it's basically fire from the initial clearing. Then the remaining slash and biomass, then there's a respiration component of that when that decomposes and decays. And then there can be some uptake from subsequent regrowth, uptake of carbon if the land is abandoned and there's a further carbon sequestration. So if it were just a simple story like this, we have some biomass here in the forest, there comes along some deforestation and it clears this amount of biomass, and then you have agriculture and it stays that way, then our problem would be estimating this amount of biomass which went up into the atmosphere. But the landscape is really a complicated mosaic of different processes in different stages at different times. So we have situations like this where we have initial clearing, we have a period of agriculture, then there's abandonment and regrowth, so somehow we have to account for this carbon which is coming back onto the landscape. There are places which go through multiple cycles of regrowth, reclearing, agriculture, regrowth, and reclearing again. So it becomes sort of a question of over what time scales are we making these estimates? Are we including this full time scale or just the initial clearing? How do we account for the possibility of regrowth? So you can see then why these estimates might vary the way they do. So now our first question in getting a handle on these emissions is just this one. How much, over what area, and how much biomass is lost in this initial clearing? So that's sort of problem number one. And that's where our one place where the remote sensing tools come in, to be able to monitor the area of deforestation. So we're talking about large areas over the pantropics to get a handle on this. So what tools have we had? We've had the Landsat and Landsat-like sensors, Aster, Sieber, so on, which have been the workhorse of this type of analysis, where we have a pretty good spatial resolution. So a 30-meter resolution going back into the 70s. But the problem is it's like polka dots in spaces and in time. This is not a continual coverage. And there are cloud cover problems. There's acquisition, which didn't, data which wasn't acquired in previous decades. So this is just like spots around the landscape. Since 2000, we've had the MODIS sensor, which is providing really useful information, but at a coarser resolution. The finest resolution is 250 meter, and daily acquisitions. And this is starting to provide us some good information when the scale of clearing is commensurate with the spatial resolution of the sensor. And this is free, which is making it really possible to be able to use throughout the world. But that's only since 2000. So as usual, it's a trade-off between sort of coarser resolution more frequently and finer resolution sometimes and someplace. So that's the trade-off. What we've had also is the data set from the Advanced Very High Resolution Radiometer. So this was a sensor which was launched in the early 80s, which was not at all for the purpose of looking at land cover change or anything like that. It was a meteorological sensor. So some people, Jim Tucker and others, have been very creative in figuring out how to use these observations for land use questions. So that goes back to the 1980s, and it's daily and it's global. The problem is that it is pretty high, pretty coarse spatial resolution compared to the phenomena that we're looking at. So each pixel is 64 square kilometers, which is pretty coarse. So what we did earlier on, a couple of years ago, is to wring all we possibly can out of that AVHR coarse resolution data set and combine that with the higher resolution Landsat and get a depiction of deforestation throughout the 80s and 90s throughout the tropics. The estimates that are in the literature about the carbon emissions from deforestation for those time periods have been based on the information from the Food and Agriculture Organization, which is a sort of a national reporting. So countries report to the FAO, and then the FAO compiles that and puts that information together, and you get sort of one number per country. And there's lots of reasons why you can imagine that some countries may be accurate and some countries may be very inaccurate, and it's not a spatial information at all beyond the country level. So there are a lot of questions about the FAO data. So applying the remote sensing analysis of deforestation and using this kind of bookkeeping approach to be able to estimate the carbon emissions, we came up to the conclusion that the carbon emissions from deforestation, the net carbon flux for the 80s and the 90s was considerably lower than what has been in the literature and what has been used by the Intergovernmental Panel on Climate Change. About almost half as low, which is kind of a funny thing to say, that the carbon emissions from deforestation have been overestimated and the deforestation area has been overestimated by the FAO. So that's the conclusion that we came to. Now our colleagues in Europe, Frédéric Achard and his colleagues, were doing a similar analysis, and neither of us knew that each other was doing this analysis. They beat us to Science, so they're published in Science, and we're published in PNAS. But nevertheless, they did this similar analysis using the Landsat data record. So they looked in a few we looked everywhere with coarse resolution. They looked in some places with fine resolution and did the same thing, used the bookkeeping approach. And they came to a very similar conclusion. We really honestly did not know that each other was doing this work. So they came to the conclusion that in the 1990s, the tropical deforestation net carbon flux was around 0.96 petagrams or gigatons of carbon per year, and we came to 0.9. And both of these were considerably lower than the existing estimate. So that's kind of a strange thing to put out there if you're working on this issue, but these two analyses came to a similar conclusion about that. But that's in the 80s and the 90s, and maybe we'll never quite sort out exactly what happened in those decades. So our challenge now is to sort of move forward and use the tools that we have now and look at ways where we can reduce these uncertainties and move forward with our understanding of carbon emissions from deforestation. So when we go into this decade, we see a really, really different changing dynamics of tropical deforestation in some places. And this is all related to the sort of revolution that's going on in the tropics with commodity production and international trade and movement of soy to China and all of these issues that are tied up in globalization. But that plays out on the landscape, and we can see that very clearly on the landscape. So this is the Amazon basin here. This is where we've been working here. This is the area of Rondônia in Brazil, where in Frank in our graduate student days, that was our poster child of deforestation. So the image that we have there from our sort of mindset of deforestation is this fishbone kind of clearing, where we have, this was a planned settlement here to move landless peasants and give them some land and secure the Brazilian borders. And the result on the landscape is this fishbone pattern where there are these roads and deforestation along the roads. These dots here are active fire from the MODIS sensor. So you can see that the fires go along with where the deforestation is occurring. And these fishbones here are these roads that you see here. So this is a very linear, very planned, and you see the deforestation occurring along this fishbone pattern. So that's kind of our standard 80s view of deforestation. If we move a little bit to the east here, this is the state of Mato Grosso, and that accounts for about half of all the deforestation in the Brazilian Amazon. You see a lobe down here of forest cover, and that's an indigenous reserve, which is another interesting story. And the spatial pattern of deforestation that we see here is nothing like the fishbone patterns. It's these big clearings, big patches. You see the fires associated with that. And what that is on the landscape is these huge, massive clearings. I mean, you would think you were in Iowa or Kansas or the central Asia or something, where there are big mechanized agriculture, big clearings, and completely cleared out of biomass in preparation for mechanized cropland. So it's a very different dynamic of deforestation that we're dealing with in this decade. Not that the small-scale deforestation is not important or it doesn't occur in some parts of the world, but particularly in this part of the Brazilian Amazon, in Southeast Asia, where there's the oil palm issue, we're moving towards a different dynamic related to the basically globalization and production of commodities in the tropics. So this issue of the expansion of mechanized cropland in Brazil is basically about the increase in soy production. So you can see here that the annual soybean production has just really skyrocketed between the early 90s and now, and It's important for the Brazilian economy, and I would be the last person to say that there should not be deforestation or there should not be an increase in soybean exports, because it is important for economic development. But it's a relatively new phenomena and a big increase in production. And Brazil and the U.S. kind of swap back and forth now about which is the largest producer of soy, but Brazil is a big producer of soy now. And some of that is being exported to China for feed. And you can see here the increase in the annual meat consumption per capita in China going up with economic prosperity. So we all know that with increasing income, increasing meat consumption. And what's feeding that meat consumption, at least partially, are the soy that is being exported from Brazil. So just going back to this map now, what's happening is there's a road that's being paved up here, going up to the port in Santarém to be able to export out to Brazil this way. And there is a road which is being paved out this way through Peru to be able to export out to Asia. So it's a big push in terms of infrastructure development. So the issue here has been that some people have claimed that this increase in production has occurred, soy production, has occurred without any increase in deforestation. So that argument takes the line that there has been forest which has been cleared for pasture, which is the dominant land use following deforestation in Latin America, and that land which has already been cleared has gone through this sort of secondary clearing process, intensification process, and is then used for mechanized cropland. So the argument there is it's already been cleared, it's a process of intensification, no new deforestation. The other side of the debate goes that this increase in soy production is leading to massive deforestation and the destruction of the Amazon. This is sort of the Greenpeace line. That there is forest which is being cleared directly for cropland, and this is massively increasing deforestation. So this debate has gone back and forth, and whichever side you take is whichever suits your perception of what you want the public to think. And what we did was we used some remote sensing tools to just try to shed some light on what these dynamics really are and see if we can sort out what happens to a parcel of land when it becomes deforested, which the Brazilians have their monitoring system, which they track very well, but they don't track what happens to it following the initial deforestation. So for each of those deforestation polygons, which the Landsat analysis identifies, what happens to them? Do they become cropland? Do they become pasture? Do they not get used? Do they get abandoned? What happens? So there MODIS comes in very handy. And the reason why MODIS works in this landscape, again, this is the state of Mato Grosso. This is an indigenous reserve here. And these either yellow or red clearings is all the deforestation polygons between 2000 and 2005. So MODIS works very well here because these clearings are so large that they are observable with the 250-meter resolution. Would not work in places where there's small-scale clearing, which is many other places in the Amazon and elsewhere. So the way we used the MODIS here was to use the daily information, clean it up with the process I was talking to Jeff with before, and be able to get the phenological signature of different land uses following deforestation. So for example, this is a vegetation index. So this is just the greenness, the amount of photosynthesis is going on. So a forested pixel stays green all the time, all year round. A place that has been cleared for mechanized cropland, we see a very distinct, very green signature at the height of the growing season, which is around January, and a second crop here. So going through the years, you see that very clear pattern. And a pasture signature has some seasonality to it, but nothing like what we see with the mechanized cropland. So it's pretty clear signature for this fate of land use, what happens to it after it gets deforested. So what we found was, as usual, neither of those extreme sides of the debate are true, that the truth, or this evidence suggests that what's really happening is something in between. That about, at its peak, about 23% of all deforestation in this time period, in this state of Mato Grosso, was being used directly for mechanized cropland. So it is not true that there is no new deforestation resulting from the expansion of cropland or expansion of soy production, but nor is it true that the soy production is leading to this massive deforestation, that the bulk of the deforestation is being used for pasture. So this is one way where I think the modus analysis sort of can inform the policy and has informed the policy. And there has been discussion back and forth then about the soy moratorium, and Greenpeace was pushing this, and the day before Greenpeace announced it, McDonald's announced that they were doing their own soy moratorium. So it's a quite active policy discussion, but the ability to actually track what's going on is an important but insufficient piece of that policy discussion. So what did we find from this analysis? One thing we found was that the amount, this is a total amount of deforestation for these years in this state of Mato Grosso, that the variability from year to year is really largely driven by the amount of clearing that is going for mechanized cropland. That's the purple down here. So this year was 2003, lots of clearing for mechanized cropland, and the soy price was at its all-time high. So you can see, this is the soy price. So you can see a pretty clear association between the total amount of deforestation in this state and the price of soy. And that comes back now because the price of soy is way, way up, as all grains are now, and deforestation seems to be up again after a few years of decline in 2007. So how much is caused by climate, how much is caused by the price of soy, how much is caused by policies aimed at deforestation, all of that is very difficult to disentangle, but there does seem to be an association between the price of soy and the amount of deforestation in this state over this time period. The other thing is, from here, we see that these purple places, these places which are being used directly for mechanized cropland, are huge, enormous, hundreds and like over 500, a disproportionate number of them are over 500 hectares, which is an enormous clearing. So they're big, and they vary from year to year, perhaps with the price of soy. So why does it matter for the carbon story? Well, it matters because the amount of biomass that remains after the clearing really varies with these different fates of deforestation. So those places which are cleared out for mechanized cropland, I mean, every stick of biomass is cleared out. I mean, there is just nothing there. Really, pretty much almost complete combustion completeness from those fires. So these, the biomass is pulled down, it's left to dry, piled up and burned, and then piled up again and burned, and that process leaves us with a very not any biomass left on the landscape except some places around. There's probably a home in there. As opposed to those places which are used for pasture, there's a good bit of biomass that's left remaining on the landscape. Could be up to a third or so of the biomass which is remaining. So if we're trying to get our carbon emissions to the atmosphere right, we need to know how much of this biomass is going into the atmosphere as a function of these different types of land use transitions. Some places there's very clear evidence that there is this secondary transition from pasture to crop. So here's a place where there's I don't know if you can see that, it's kind of dark. There's a fence here, and there's a mechanized farming going on behind that. So it's very unlikely that this fence was put in here to keep these soybeans from running away. So there's, it's pretty clear indication that there's a lot of this secondary transitions going on. And other places are just cleared and not put into production for some reason or other. But the big issue for the carbon story is how much of the biomass is removed. And this difference in combustion completeness really is evident from the fire, our observations from the active fire, the modus active fire product, where those places which are being converted through to cropland, we see a higher frequency of active fires than with the pasture conversion. So that's another indication that this combustion completeness varies with the fate of deforestation. So some of our work has been to fold all of this information. What's the land use following the deforestation? Where are these active fires occurring? The Brazilian Landsat-based deforestation monitoring, all of these pieces of information, and try to fold that into a spatially explicit model. So this is pretty different from the bookkeeping approach, which has been used previously. So put these all into an ecosystem model based on CASA, if any of you are familiar with that, and basically grow the biomass and then burn it as a function of where it occurs and what the fate of deforestation is, and estimate the carbon emissions from deforestation using the tools that the community that has been working on fire emissions has used. So we haven't really before linked up the fire emissions approaches with the deforestation emissions, but basically the deforestation is a fire emission problem, at least that initial part. So what I want to share with you is some of the lessons that we're learning from this modeling exercise, and we're still going through it, but just some of the things that are coming out of that modeling exercise. So one of the things is that there are gobs of fire across the tropical landscape, and pretty much all related to human activity of some sort or the other. Most of those are related to pasture maintenance, burning to keep the production up for the cattle. That's most of the fires that we see. I think that's pretty generally true across the tropics. But those fires don't really amount to much in terms of carbon emissions, not a lot of biomass that's being burned. And that the conversion fires, those fires which are actively doing the deforestation, are cover less than 50% of the area, but they're the bulk of the emissions. So if we have the ability to sort out which fires are leading to deforestation and which are just the sort of maintenance fires, then we can use the fire information in a better way than we've been able to use before in terms of monitoring deforestation. Another observation that comes out of this modeling exercise is that there's lots and lots of small deforestation events, and small in this context means less than 25 hectares. In a different part of the tropics, that would be huge deforestation, but here, less than 25 hectares is really small landowner. And that there are lots of those small deforestation polygons, tens of thousands of those throughout the landscape. But when you look at them in terms of the area, the proportion of deforestation area that they contribute to, and even more so the proportion of emissions that they contribute to, they are pretty small. So we have sort of 70-ish% of the deforestation polygons being small, but in terms of the emissions that they're contributing, it's on the order of 10 to 20%. So in terms of the policy implication, that would suggest, all else being equal, that if we want to target those clearings and those land use actors which are leading to the bulk of the emissions, it's not these small-scale farmers, these small clearings, it's really these big clearings. And again, that's a conclusion that applies to this part of the world. But again, this is half of the deforestation in Brazil, which is a substantial amount just in this one little state. But it gives us some clues of where policies might be effective in terms of who gets targeted and how much bang for the buck do you get from targeting different land use actors. Another observation is that these fires associated with deforestation, they occur over a number of years. So we tend to think of deforestation, it occurs in 1 year, boom, that carbon goes into the atmosphere, and then we move on to the next place. But that is not actually what occurs, that this process of clearing, piling up, drying, burning, and piling up again and burning some more goes on over a number of years. So this is one particular deforestation polygon, and the dots are the fires. So you can see these fires continuing on for a number of years. So this suggests in terms of the policy, first of all, if we're from a science point of view, if we're estimating the carbon emissions to match, to try to get a handle on what's contributing to the annual CO2 growth rate in the atmosphere, we have to account for this multi-year policy, multi-year emissions. But in terms of the policy, it seems pretty difficult and impractical to go for a system which would do an annual, based on an annual estimate of carbon emissions from deforestation, because this process occurs over multiple years. So any policy that thinks about some kind of annual credits would really be very difficult to implement, it seems. A fourth observation is that knowing the fate of the deforestation, the land use transition type, seems to be important in getting these emission estimates less uncertain than they are, and that these emissions are not proportional to area, that we need to take into account the fate of the deforestation as well because of the combustion completeness and the amount of biomass which is left on the landscape. So these are some of the science and policy implications of what we can learn from a more detailed modeling, spatially explicit modeling to try to improve our estimates of carbon emissions. So I'm going to skip through this quickly, but in terms of are we getting these numbers right? Well, we never know. We don't have an independent verification. There's just nothing that can tell us if we're right or wrong in terms of the atmosphere, because all of these different processes are contributing carbon to the atmosphere. So how do we sort out this one? So we don't have any truly independent verification, but we can compare to some other approaches. And one approach is to compare with the DCAF, which is what we call our model, with the bookkeeping approach that has been used, the non-spatially explicit. And we seem to be coming to some pretty decent agreement when we aggregate over large spatial scales and time. We're not totally out of the ballpark. Another comparison is with the fire emissions estimates that have been done globally by Jim Randerson and his colleagues at UC Irvine. And again, if we look at the part of the world that we're looking at with this detailed modeling, and we certainly have differences on a year-to-year basis, but if we look over the whole time period and the whole spatial extent, we're in pretty reasonable agreement. So at least we can get some convergence that the numbers we're coming up with are not wildly different from these three very different kinds of approaches. So based on this sort of prototype development of this model in this one particular part of the world, what do we learn? That this new dynamic of deforestation, which is driven by commodity production basically, requires us to think about our methods for estimating carbon fluxes, that these multiple methods seem to be coming to some kind of similar estimates, so we're not wildly off, although we still have a good bit of work to do, that getting these land use transitions and the interannual variability seems to be important. Then the issue becomes, how do we really scale up to the whole tropics? So we can't know in detail the fate of every single piece of parcel of deforestation everywhere throughout the whole tropics. So what we're working with now is how can we take what we've learned in this one part of the world and apply the approach to the whole tropics. So what do we have to work with? We're learning from the MODIS analysis of where the deforestation hotspots are for the current decade, and Matt Hansen is doing a lot of that work. So again, the arc of deforestation in Brazil and in Southeast Asia. I think we have a pretty reasonable handle on where the emissions are, where the hotspots are, and how do we combine that with our fire emissions, with atmospheric optical depth, which is a good indication of where there's fires, with MOPIT, carbon monoxide, with a whole range of data sets to put together all of these approaches in a modeling framework and be able to do better at estimating carbon emissions across the whole tropics. So that leaves us with, I just wanted to leave you with a couple of questions which are really out there and seem to be important for getting at the policy discussion. And one is, what I mentioned before, is which land use transition types really matter? Which are contributing the bulk of the emissions? If we're going to decide on policies, where would you put your efforts in terms of being able to get at the largest source of emissions? And in the entire Brazilian legal Amazon, as is the case in Mato Grosso, the number of deforestation events or polygons from these very large clearings, these greater than 100 hectares in this case, are really small, like 5% of the clearings are very large, but they contribute about 50% of the deforestation area, and that's in the entire Brazilian Amazon. So this is a very, very different actor than this actor. This small-scale clearing and the policies for addressing these two would be very different. So, you know, I don't know if that argues that this should be the focus because this is low-value carbon, or this is very high-value carbon because of the value of the commodities that are being produced. But it does tell us that there are really different, what the relative contributions are from different actors. Another question that's out there is the soy expansion, even though it may not be leading directly to new deforestation, or that's mostly coming from pasture, but is that pushing the past deforestation for pasture further up into the Amazon? So this is census data, agricultural census data, put together by Bob Walker. And we see the soybeans agricultural census from 1990 to 2005, and you can certainly see how it's moved up along the frontier, and the pasture has moved further into the frontier. So is this pushing this further into the frontier? This is kind of difficult to disentangle analytically, but it's a question that a lot of people talk about. The other issue is that what is the relationship between a dry year and clearing? In 2005, the state of Acre over here, it was a dry year in this part of the Amazon, and there were lots and lots of fires, lots of publicity around that. This year, in 2007, it was really dry in the eastern Amazon, and there were lots and lots and lots of fires, more than have been observed. So what is going on here? Is it the case that in dry years, are these just more escape fires because it's drier? Or is there some feedback to the deforestation decision-making process in dry years, that it's easier to clear when there's less moisture, easier to burn, and you can do more clearing and clear more area? And is that a sort of positive feedback that if a drier year resulting in more clearing, which puts more emissions, which leads to more drought, and et cetera, in a positive feedback loop, is that occurring or not? That's a sort of open question out there, and that is likely to vary with different land use actors. So what's happened? Almost done here. What's happened this year is very interesting. When the Brazilians came to Bali in December, the word was that deforestation rates were continuing on a declining trend, that the peak had been in 2004. Then in 2005 and 2006, the deforestation rates were declining, which seemed to actually be true. And the report in last December in Bali was in 2007 that trend was continuing, a declining rate of deforestation in the Brazilian Amazon. Then subsequently, recently, there's been a whole bunch of press reports, got a lot of play in the press, that the Brazilians have reported from their monitoring system that that there's been this big increase in deforestation rates in 2007, later in the season, in the burning season, than in previous years, that we're back up to high deforestation rates. Is that related to the soy price going up? Is that related to this dry year in 2007? Is that related to something else? Don't know. That's an open question. So getting to the policy perspective now, what does a policymaker see, and on what basis does a policymaker have to go forward with this whole uncertainties around carbon emissions from deforestation? The policymakers see all of this science boiled down to this one number, which is an average of all the published reports. And what we have now is this sort of generic, it's just gotten in there somehow that deforestation contributes 20% of the carbon emissions to the atmosphere from anthropogenic activities. I think that's high, personally. I think that's on the high end. Doesn't really change the policy discussion, but it's interesting how these numbers just get into the discussion. And what we've been trying to do is to work through an international group, the Global Observations of Forest Cover, through an FAO system, to just not put forward our policy prescriptions, but put forward what's the technical capacity for monitoring deforestation and estimating carbon emissions. So just from the purely technical point of view, what is possible? How could this be done? So working in an international group, we've put together some reports just aimed at informing the policy discussion on the technical capacity. And what we're saying there is that there's a variety of methods that are appropriate to monitor change in forest cover at a national level. That's only done in a few countries now, but it is technically possible given that data would be made available and capacity, technical capacity would be developed. But there's no reason why that couldn't be done. The whole issue about degradation is a big policy discussion right now. It's much more challenging from a remote sensing technical aspect point of view. And that this, I talked a lot about the uncertainties of estimating the carbon emissions, but there are within the Intergovernmental Panel on Climate Change agreed upon methods to look at changes in carbon stocks for the existing Kyoto Protocol, and that is there and available, agreed upon by all the countries. So there is a way forward while we continue to work on the science. Some countries do have monitoring systems in place, and very nice ones and transparent ones. Brazil, India, and Bolivia, and the big advance is that it's transparent. You could go on your website right now and download the results of that deforestation monitoring. So that's really opens up a whole new level of discussion when these results of monitoring become transparent for anyone to look at or challenge and use that to improve estimates of carbon emissions. So now, just to finish, we have a lot of work to do on reducing the uncertainties of the carbon emissions, which are actually getting into the atmosphere. We have a lot of work to do to build up capacity to monitor forest area. But that, as I said, pales in comparison to the work that the policymakers have to do. So there are some really big policy questions out there, more difficult than the science ones. One of those is, should degradation be included in this red discussion or not? Again, we have different countries in different stages of these trajectories. Central African countries, for example, are certainly not in this stage. Their issues are more logging and degradation. So if degradation is not included, they don't have, how do they come to the table? These countries here, Costa Rica, China, India, they need a piece of the action in terms of sequestering carbon. Otherwise, they're not going to agree to this policy. What's the baseline reference? Should this be a market mechanism or a fund? How do we ensure permanence? The issue of co-benefits for conservation and biodiversity, which we talked about earlier today, are really big. How do you promote that? And probably the most important issue, and it came up really strongly in Bali, is this, the question of the equitable distribution of benefits from REDD. There's quite a concern on the part of indigenous people and forest people that, once again, they'll be marginalized and thrown out of the forest, and somebody else will get the benefit of preserving those forests. So that is a really big issue about the equity question. So difficult policy discussions which will take place over the next couple of years, but we, from the science side, we just keep providing the technical input that might be useful for the policy process, might not, but that's what I see as our job here. With that, I will just a couple of publications if you're interested in that, and thank you.